Started.
You started that video.
Okay. So 3, the correlation coefficient, because 1 and 2 are both true. That was by the time we finished. Yeah.
The correlation coefficient used to quantify.
It's the direction and strength of a linear relationship.
Okay.
So A.
Yeah.
Correlation coefficient is negative when one variable increases.
When an increase in one variable is associated with a decrease in the other, we say there is a negative association.
So
the other variable
decreases.
tends to decrease. C.
Okay.
The effect of outliers on the correlation coefficient is not significant.
I believe that's true.
Yeah.
It is not significant. Outliers don't.
Let's see.
Notice how 1 point can influence. So it's significant.
Look at that. Show the answer to it.
Outliers can
Yeah, so
dramatically
that's
affect-
false. They are significant.
Yeah, I was gonna say right here. It says notice how 1 point can influence the correlation coefficient.
Yeah.
So the correlation coefficient between duration and weight of the old faith XLS data, your answer should be exact. So to pull up the old faithful data. Yeah, this is and then which one do I put this into?
Put it into the
So the correlation coefficient
what one
can
is
be
it?
calculated easily. So using any cell in an Excel page,
Quantitative
the command is,
inferential.
Inferences.
there's your command,
Okay, so you do
equals CORREL, and then array 1 for array 2. For array 1, highlight the explanatory variable. For array 2, highlight the response variable.
I don't know which one's which.
So array 1 is going to be your left,
Is that correct?
and then array 2 is going to be your
Duration and weight.
Yep. So what is it?
0.9.
0.9.
Would it be 901?
Your answer should be exact.
So
So what is that?
0.900
So you got 0.8.
859.
Was that
Oh.
the answer?
Let me see if I take it over. No, keep going.
It's gonna go on forever.
Well, if it wants it exact.
Exact can mean
Yeah, how much is it?
Is there an inference? What's the? Does it say to put it into one?
My guess
this is correlation coefficient between duration and weight of the old faithful data.
covariance.
Is your answer should be exact. What does exact mean?
My guess is it's just the 3 decimal places we've been doing.
Okay.
So I'm doing 9. And then the covariance.
Of duration and weight of the old faithful data. So how do we do covariance?
The covariance is a measure of how 2 variables vary together.
Where's that at?
We compute, it's number 4.
Okay.
It's calculated by multiplying them together.
So multiplying which of the
So S times XY equals R times SX times SY.
My alarm was going off on my watch, and I just turned it off. I don't know what's going on.
Okay, in the reading,
Using the file math self-efficiency, compute the standard deviations. So,
okay, which one is it? Sorry.
4. Less than 21.
Now the
Oh.
what's Excel sheet?
math, oh, it's a file, math self-efficiency. And that'll give you the standard deviation of X and the standard deviation of Y. Now we have the correlation coefficient.
So what I'm supposed to put it into one of these would be
So, yeah, so you put each variable in and find your standard deviation for each variable.
So it'll
'Cause
be
it's-
this with the difference, or no?
Well, because it's R, so R is the number that we just got, the 0.901, times by the standard deviation of each column. So
Okay.
each one. So you're gonna do just your one sample test, and because you're just gonna want the standard or the
but there's
The standard
the
deviation.
score and the confidence.
no, not for that one. We're still doing the Old Faithful.
Oh,
Okay.
okay. So the duration and weight.
Yep.
Uh,
Okay.
So what do? We don't compare the two together?
No, so it's your standard deviation of one times the standard deviation of the other times by your
Okay, so
covariance
Okay. So the
deviation.
standard deviation.
is 1.139.
Just leave it there. And then I'll-
Let's say here, I'm just gonna plot my calculator. Okay, so that was 1.139 times by 0.901 times by, what's that one? Or the next one? 13,595.
And then what do we do after that? Is it just that times that?
That times by your correlation coefficient, which what we found in 6, which is 0.901.
I got 13.95.
That's what I got. It says round to one decimal, so 13, so 14. 14.0.
Yes, that makes sense. But
Because you're only going to round to one decimal.
so associate the scatter plot with the correlation coefficient.
So we got 0.901 and then just 14.
Correlation coefficient.
So 0 is going to be C. C will be your 0 because there's no correlation to any of that.
Oh, I see. And one would it be D?
1 would be A because
It's
it's all in that
positive.
straight line. Yeah. -1 would be D.
Oh, I see.
Because it's opposite.
Yeah. And then
9.
0.95 would be B.
Why? Because it's
Because it's still positive and it's
Okay,
almost all
but
in a straight line.
yeah, that makes sense.
And then -95 is E.
So
There is-
0.95 is B, and then it's E for the opposite for
Yeah.
12.
E,
And
and then
F.
would be
So 0, would that be C? Because the other one is -0.6, and
Yep.
that's going, so
so C0 because your line is going to be pretty much flat.
yeah, that's what I was thinking, because then we have the -0.6, and it's scattered, but it's still going in that,
In a negative trend.
yeah.
Yeah.
Okay.
The correlation coefficient between scores and confidence of this.
Math self-efficiency data is
Okay, so how do I do this one?
So you take the data from the math, whatever. So the score, you find the correlate, or
the score and the confidence. So your correlation
With-
coefficient.
so we do the
split-
correlation coefficient of those two.
So that's
But do we split it up because it's male and female?
no.
No. So we do that.
So
What
that
was
one-
it? CORREL.
CORREL. Yep. And then 1 in the other.
Excuse me. So 0.729, and then so
And then-
that's
so we
that's
need,
14
yep. So we need that one.
And now you do what we did last time.
with the
Yeah. We just need the standard deviation of both of those groups.
Well,
We just got the one.
Dude, I know there's a command that you can do to go to the bottom. I just
Right click.
and
Okay,
it's
so that standard deviation is 16.376.
376 times the standard deviation. Zero 0.93 times 0.939 times the correlation coefficient, correct?
Which was 0.729.
It's 11.209.
And it's the 2
Point
spots, so 11.229.
729.
Yep.
1.1.
Well, you're rounding to 2.
Two
no,
decimals is
Yeah, but that's not what I got.
1.12.
I got 11.21.
So did I.
Okay, so I did this times oh I did 0.0, but it's point.
Cool. And that's all.
Good
Still
job.
here the whole time, getting
To the end. 1 through 15.
in the window.